Okay, so welcome to 5.3 areas, units of area and volume. Emphasis again on units, different units, and what area and volume are. So the metric system is kind of designed this way. A milliliter, which is a thousandth of a meter, was defined as the volume of a cube measuring 1 centimeter on each side. And we know that 1,000 milliliters equals 1 liter. So there's 1 liter and 1,000 milliliters, but 1 milliliter itself, 1 milliliter is a centimeter, a cube made of a centimeter by a centimeter by a centimeter. So when you multiply 1 times 1 times 1, you get 1, and you multiply the units, right? Centimeter times centimeter times centimeter, you get centimeters cubed. Cubic centimeter, which is written sometimes like this and sometimes like this, is thus a unit of volume, like a gallon, but it's a cubic centimeter, it's smaller. Notice that 1 liter consists of 1,000 cubic centimeters. So 1 liter is 10 centimeters by 10 centimeters by 10 centimeters. Length times width times height. 10 times 10 times 10 is 10 cubed, which is 1,000. Centimeter times centimeter times centimeter is centimeter cubed. Most people never stop to think about why we read 10 to the third power as 10 cubed. It comes from the fact that a number multiplied by itself 3 times gives the volume of a cube with side length that number. The Greeks were the first to think of these numbers geometrically. Note that we cube the units as well as the numbers. When we add the units, we do not add the units, but when we multiply, we do, right? Similarly, we read 10 squared at 10 to the second power as 10 squared because it represents the area of a square with length of sides 10. There are 10 millimeters in every centimeter, so there's 100 square millimeters in a square centimeter. So what's important to know is that we measure volume in cubes and we measure area in squares, square units. These images are important for you to study. So we're going to turn to the length, a millimeter, centimeter, inch, etc., into units for area. So we take units for length and turn them into units of area by squaring them. And units of volume we take the units of length and cube them to find volume, right? That's how volume and area are defined. The squares are fundamental unit of area. We can measure the area of geometric shapes using squares. So we're going to find the area of this shape. It's hard to do. You'd probably want to use a formula because there's probably some consistency. The same here. There's 1 square, 2 squares, 3, but what are these? And this is really tricky, a circle. How many units are in here? So here's one formula. The area of a rectangle is the length times the width, but you also multiply the units. So it would be 10 square centimeters. That's the area. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The area of a rectangle is the length times the width because that gives the number of squares it covers, right? 5 times 2 is 10, multiply the units also. If that was inches, it would be square inches. Similarly, the area of a triangle can be thought of as half the area of a rectangle. But first, we'll create a parallelogram consisting of 2 triangles. So a parallelogram is right here. It's sort of like a rectangle, but it's been like pushed down. So then what we're going to do is take this triangle here and cut it out and move it over and put it here. And that's going to give us then a rectangle. And once we do that, we realize every parallelogram has the same area as a rectangle. Base times height. This base times this height gives us the area. See, we take that and we move it over there and turn it, and we have a rectangle. So the original triangle is half of the rectangle, giving us a formula for the area of a triangle, which is 1/2 the base times the height. So this triangle here is 1/2 the base times the height. The other important one is the area for the formula for circles. The other area formula every quantitative auxiliary person should know is the area of a circle. The area of a circle is pi times the radius squared. We're going to show you how that came to be. The circumference of a circle is pi times the diameter. And remember, the radius is twice the diameter, so diameter equals 2 times the radius. So it's really hard to find the area by counting the little squares. So all of a sudden we have this strange symbol that showed up, pi. The Greeks could measure the distance around any circle, called its circumference, by drawing a circle in the sand with 2 sticks connected by a piece of string, and then laying the string out and measuring it. This circumference that they measured, so they just take a circle, put a stick in the middle, a stick around it, draw a circle, put a string around it, cut the string, and then roll it out. And the length of that string then would be the circumference. And this circumference was almost always exactly 3 times the distance across the circle, the diameter. So the circumference was almost always, it's just a little bit more than 3 times the diameter. So from the Greeks, their circumference was almost always 3 times the diameter. So the ratio between the circumference, which is the measurement around it, and the diameter is pi, which is about, it's an irrational number, it goes on forever, but that's a slight approximation. So this definition of pi, which is the circumference divided by the diameter, equals pi, gives us a formula for the circumference, which is 2 pi r. How does it do that? Well, look, here's the equation here. Multiply both sides by the diameter, and the diameter will cancel over here. It'll come up times the diameter here, and the diameter is twice the radius, so the diameter equals 2r. So 2 pi r is the circumference of a circle. So we'll come back to the circumference in the next one. So if you take the measurement, the Greeks took the measurement of the circumference of a circle and divided it by the diameter, and they always came up with this number that's an irrational number. But the Greeks didn't have irrational numbers. In fact, they didn't have anything close to that. They did have fractions, however, and they could really good at measuring anything that had straight edges, like this pentagon here, or this 6-sided figure here, or this 8-sided figure here. All they knew about pi, that it was a little bit bigger than 3. So Archimedes was one of the first ones to get a very accurate approximation using polygons. So he'd take the inside polygon, figure out the area, take the outside polygon, and he figured that that was pretty close to being the circumference. So the length of the perimeter of the polygons then approximate the circumference. And once you approximate the circumference and divide it by the diameter, you get closer and closer to what pi actually is. Now, to get the area of a circle, which is up here, he's looking at the circumference. To get the actual area of a circle, you can cut from the center out, cut these little triangles, make them smaller and smaller. So we cut out all these triangles here and put them here, and then all the white triangles get fed in there, so they put them there. So they knew that this is pi r here because that's half of 2 pi r, which is half the circumference of a circle. And you know that that's the length of there is r. So if you take pi r, you almost have a rectangle now. See, you got a rectangle. The length is half the circumference of a circle, and that's the length of the radius, because that's that cut. And these are almost square, so it looks almost like a triangle. I mean, a rectangle. So if you multiply length times width, you get pi times r times r, which is pi r squared. So there is the area of a rectangle. It's a really good video, the next one up, on how you can cut these into infinite pieces to get pi really exact as you want it. Using the area of a rectangle, get back to the area of a circle. So we actually use the area of a rectangle to get the area of a circle. Hopefully you now appreciate that area comes back to rectangles and squares. But it's important for you to know that these units of area and volume convert between them, right? You can convert liters into cubic centimeters. So volume can be moved and changed into cubes of different types. So the next video we'll start will be 5.10.